So the first step is to switch on the camera right here, right on the upper left corner right here. When you turn it on, you should see the light on.
Right.
Right, the light's on, so the camera is ready to take pictures or like look at the multi-plate. The next step is to switch to open the gate, the door. Okay, the door can be opened by two ways. One is click this button. You can click it and then move the cursor away, or you can come here. You can see right here, it has a green button.
Right.
The green button. Press it, then it's going to open. So right now we have some problems with the door. Sometimes when you load a plate or exit a plate, the door won't be closed. It's okay. If the door is not closed, it's okay. Just ignore it. It's not going to affect our internal operation. So I'm going to just press the button. When it's green, right?
Can I?
Yeah, press it. You see, it changed from green to orange, yellow. And the door is going to open. Okay?
Right.
So when the door is open, you are going to hear a click noise. A click that means it's on position. Just wait. Right?
Yeah.
So that means now it's ready to go out plate. And again, you are going not necessarily wear gloves. Okay? Hold the plate, be careful, don't drop the plate.
Right.
And right here, you see, you have an angle, right? This angle need to face in. Otherwise,
I see.
if you do something like this, it's going to mess up everything, and then it's going to damage the instrument. So make sure the plate, the angle need to face in.
Right.
So you load the plate, you sit on the holder here, press it back until this guy touch the back or this plate.
Can I? Right.
Yeah. Yeah. Hold it back. Yeah, like that. Good. Okay. So after you put a plate on the arm, on the holder, you can either press this button or you can go just come here.
Okay.
Yeah. You can click on this button and then you move the cursor away.
Right.
Right now you see it's up, right? Up.
Right.
That means the plate is upside. Once you click this button, it's going to start talking. Once it finishes talking, it's going to change to in, IN.
Right.
A little bit. Click it and then move the cursor away. Okay. So that's it. Right here it's loading. And the door right now is supposed to close, but right now it didn't, right? It didn't close the door. It's okay, just ignore it. Yeah. So look at here, this is the vacuum reading. This is the important part, okay? Right now, it's loading the plate for atmospheric pressure into the source chamber, which is a very, very high vacuum. Okay, 10 to minus 7 rate, right? And right now, it has some buffer zone. The buffer zone is going to open one door, and then load the plate to the buffer zone, and then close to the other one. And then after that, it's going to load the plate from the buffer zone into the source chamber. That's why the reading of the source high is going to drop to 10 to minus 4 or minus 5. And then once the gate closes, it's going to power down. So I like this reading to be at 10 to minus 7 range before we go to the next step.
Okay.
The set point is 3 times 10 to minus 6. But I like the vacuum to be even lower at 10 to minus 7 range.
Right.
Okay. So you can see right now you say it's fair.
Yeah.
Because this reading is higher than the set point. Okay, so right now it's loading the plate. So just be patient. It's going to take a couple minutes. So once the plate is in the source chamber, it's going to close the gate. Once the gate is closed, it's going to power down the source region. So this one is going to drop below the set point. And here, the motor is spinning to close the gate.
So you said it will come down to 10 to the power minus 4. 7? Okay.
Yeah. Okay. So I like it to be at 10 minus 7 range before we go to the. Right now you see it's getting close to the. You see it's already green. But this is below the set point. But this is not good enough. I like this one to be at 10 to minus 7 range.
Right.
Okay, so this way, be patient. Wait for like another 30 seconds or like even like 1 minute. The reason to have a good vacuum inside the source, for MALDI-TOF, they use a high voltage, right? 20,000 volt, and the vacuum needs to be good, otherwise it may cause arcing, and that's going to damage the electronic. And right now we don't have service contract. Everything need to count on our users to take good care of the instrument, right? Otherwise, if we have something happen to the machine, we have to pay the repairing cost, and it's very expensive.
Yeah.
Yeah, I got a quote from BRUKER about a service contract, and it's like 40,000 a year. Yeah, 40,000, and then right now we are charging our users $25 per sample, divided by 40,000. So how many samples we want to collect that? Yeah.
Right.
Yeah.
Understand. Very much expensive.
So
Is this instrument heavily used? Like
yeah, a lot. Depends. This way you see right here, quite almost every day. Yeah, but in most cases, it's available for you. Just come and it's available for you. Okay, right now you see, it's at the maximum range. Okay, so right now we are going to the next step. The next step is this is the window to show us the reading of the instrument. So we are going to change the window to show the mass spectrum. Okay, so to do that, go to status, details. You see, this window is going to show data. We are going to get the data from this screen. But if you want to switch it back, just do the same thing, slide toggle, right? Details, go back here. Okay, and then this is under status detail. You can switch it.
right.
Okay, so this is the window. We are going to show us the real-time mass spec data from this screen. And we can go to spectrometer. Make sure the high voltage is off. Right now it's off, right? Okay, and then we are going to load our method. The method can be loaded through here, select method, or you can go to file, select method. Either way, okay?
Right.
And then when you try to select the method, you see this pop-up is that the current method has been modified. Do you want to save it? Don't save it. Okay, because every time our users, they may have to make some adjustment, changes on the method for their samples. Okay, so we are going to do the same thing on your sample, right?
Yeah.
So right here, all the samples, they are under this folder. See a D drive methods, press control methods, MMSF.
5 to 20.
Yeah, we have the L stand for linear ion mode, P positive. Okay, LP that means linear mode and the positive ion mode. Okay.
Linear mode and what?
P positive.
Positive, okay,
Yeah.
right.
But in case you want to do negative ion mode, you have to double click this button. You all the negative method right here. R is reflection. L is linear. You know that, right? Now for the MALDI-TOF, we have the reflection mode is used for like peptide or small molecule. But for protein, always use L method. Okay, LP is the most popular one. So we are going to use the LP 20 to 50K method. Okay.
No, 5 to 20. Because
Okay, good. We use this method. Okay. Select this method, hit open. So once you load the method, this guy is going to change to yellow and then change to green. Just take a few seconds to ramping up the high voltage. It's right here. It's ramping up the high voltage.
right.
Are you interested in anything below 5,000?
Below 5,000. Right now, no.
No, okay. That's the reason I asked. Right here we have a setting right here, deflection, suppress up to 4,000. Anything below 4,000 will be deflected by the electric field. So you cannot see any data for anything below MZ 4,000. Okay. But right now,
Suppose if I want to like record below 4,000, so what I have to do?
so just change the value. But the minimum value is 500.
Yes.
Okay.
Yes.
Okay, so right here, 4,000, but we can change it to 5,000. Okay, and hit enter. Okay, so right now, anything below 5,000 will not be collected by the computer. Okay, so this is called matrix suppression. This is important because we don't want to saturate our detector by the matrix ions.
Right,
It's going to damage it. This is the right time. Okay, the next one, after you switch on the high
So
voltage.
I have to put in deflection mode.
Always on.
Always on. Okay.
Always on. Okay. So what you need to do, just double check this value. the default is 4,000. Okay, but if you are interested in something, for example, like between 10,000 and 20,000, you can set it to 8,000. Yeah, the reason to have this, if you have something like below 8,000, the peak may be very intense, and it's going to suppress the ionization, or like the peak or your protein or interest may not be see very obvious.
Right,
Also, the
right.
main peak is very intense, right? The next step is to go to detection. Detection right here, 5,000 to 20,000. I can go up a little bit more, right? Or you say 20K is okay, or
25 is also fine.
25 is fine. no
okay, let's go
problem.
to 25K. Okay. So anything between 5K and 25K will be collected. Okay. So this is a good range. Under detection, spectrometer already on. Next step is to go to our samples. But because I am a standard, I double check my standard.
Right, right.
So go to B, B1, B2 is my standard. Just click on B1. So when you click on B1, don't do anything. Let it finish the moving. We have some user, they click on the long button and then they try to collect it while the motor is moving. Not good. Okay. Okay. Let it finish. And if you click on the long button, let it finish, and then you can click on the right one. Okay.
Right.
Okay, right here you see the setting right here, 50% is the laser energy. Okay. And now we are using HCCA matrix. So the default one is about 30%. About 30% energy should be good. If you don't see a good response, you can raise up every 5%.
Right.
35 or 40. Don't increase from 30% to 60.
Right,
It's
right.
too much. Okay. Okay. So right now we can try to fire the laser. Look at here. You see this is a crystal, right? B1
Right.
and B2. See? Okay. I saw a spider. Saw a spider.
Oh,
Yeah.
So right now we are going to fire a laser on a crystal. Okay, here, stop. It's the same as you used before. If you use the MALDI before, it's the same thing from BRUKER.
yeah.
So when you click stop, it's going to take a few seconds to charge in the laser cartridge. Okay, so only for this one. And then you can see the flash. Right? You can see it, right? So look at here, this is all the standard we have. 5,734, 36.
Right.
But right here, you see, we also have another one about 17K. So, but it's not very hard, obviously. Look at here, right here. Right? To zoom up, hit this button, zoom up. Zoom in,
Which one?
17,000 is this. Right? But we are going to raise our energy a little, maybe try a different spot. It's a little bit better, right? You can see it. 16,957. 16,952. Okay, but we can do a calibration. In most cases, the accuracy is good enough for you. Okay. Okay, so I raising our energy a little bit more to about 35%. 35%. See, right? Very, very nice. Okay, and zoom up, and you can see all this is our protein mixture. And we can do a calibration. Under calibration, auto assign. This guy couldn't see it. Okay, so I'm going to zoom in this part. Okay, hit this button. Click here. Right? And I hit apply. So right now, this is calibrate. This is calibrate. Instrument is calibrate. Okay? And then in most cases,
So for the calibration, suppose if there is some change, I have to basically go there and like modify the.
yeah. But
Okay.
as I said, the mass accuracy of 1 or 2 or 3,000 for a protein larger than 10,000 is acceptable. Okay. So this is just for training. When you run your actual sample, you don't need to do this.
Okay.
You don't need to do this.
That is the thing. Like
Yeah, you don't need to do this.
Yeah. Because
So-
I know you
Yeah.
basically often take care of.
Yeah. This is already very good. That's why
Okay.
before you see earlier, it's off file 1 or 2.
Right.
So right here, I can go here, save as. Save as, you can save the method under your folder. I don't think we have a folder for your lab. We have folder for your lab.
Can you just make one?
Yeah, D, data, MMSF, and then, yeah, I think we've done something for you before. Okay.
Can you just?
Yeah, do you want to use your name?
Yes,
your
yeah,
initial? Go
my
ahead.
name.
Your
Right.
initial, something like, or your name, either one. Oh, KB, okay. Good. Okay, and then I like to have another supported base date at 05, 08, 2023, 05, 08, 2023.
2023.
Yeah, the year. Yeah, like that. You can enter. So we are going to save the data under this folder, okay?
Okay.
And just off and tap to switch back here. So right here, you can go. Save, okay? And then browse MNSA and go to your folder. It's under this folder, okay? And now we are going to give a name. So this is a peptide standard number 2. We are using HCCA matrix with positive ions, differential mode. Okay. Sorry, the cap is on. Peptide standard number 2. And then this is HCCA matrix with positive ion mode, differential, for linear mode. Linear mode, LIN, laser, 35%. Like that. So you know the setting you use to acquire the data.
Right.
Okay. Save. Okay, so we can go ahead and run your sample. What's the spot of your sample?
Yeah.